Have you guys ever gone to the bar? Are you old enough yet? Some of you, some of you don't. Anyway, so and you can imagine all the environment in the bar. So people go there, have food, have drink, start flirting with one another. If they like each other, the flirtation goes well. They exchange their number and meet up later. So imagine in this world is made of so our human is replaced by molecules or atoms. So the flirtation in the bar will be something like this. Hey baby, wanna swap oxidation numbers? And we got, that was so damn funny. I slapped my knee on that one. Once I told a chemistry joke, there was no reaction. Usually happen. Never mind. Yeah. All right, so now redox reaction and electricity. Now let's get into the what can we do with this redox reaction, right? So we talk about like so electron exchange. Now where is electricity comes from? Okay. All right. So go back to what this is like a regular example of a redox reaction. So zinc dip into the copper 2 solution. Zinc will lose its 2 electrons. So donates 2 electrons to copper, and copper takes the electron and become copper metal. And zinc loses the electron and becomes zinc 2. Okay. Oxidizing agent and a reducing agent. But if you do this, there's no useful electrical work. We can't do anything with it. Electron just exchange right there into the solution, and that's it, right? So to make use of this system, this is what we do. We separate the two systems, the zinc and the copper. Okay. All right. So we separate the oxidizing agent and the reducing agent. So the oxidizing agent is this guy here, copper 2, and the reducing agent is zinc. Basically zinc and copper, we just separate them. And in this case, we connect them with a metal wire and allow the electrons to transfer. So electron will transfer like that. This setup can generate electricity from different reactivity according to the activity series. So copper is more reactive than zinc, right? So and we call this setup a galvanic cell, right, or voltaic cell. Okay, so you will see the galvanic cell in a little bit more. So we'll talk about this cell in a bit more later. Okay, so we call this a galvanic cell. Okay, all right, let's look closer. More closely about galvanic cell and voltaic cell. All right, zinc dip into zinc. Zinc electrode is dip into zinc ion or zinc solution. Right, and again, and on the other system, the other end, so we have copper metal dip into a copper 2 solution, and copper 2 is blue. I put a color blue right there. Okay, and both electrodes are connected by a metal wire. Okay? And you could put a light bulb here, or you can put a usually they put a voltmeter, so you can measure the how much electricity can be generated. Okay, now as the reaction occur, all right. The oxidation reaction, which is on the left side right here, zinc loses electron, right? So electrons go from zinc to copper. So zinc loses electron and become zinc ion, zinc 2. Okay, when it becomes zinc 2, if the reaction as the reaction pass through, we losing zinc, right? So it would look something like zinc is so it's corroded. Okay, but because zinc is coming out into the solution. On this side right here, where oxidation reaction occur, we call this electrode an anode, a negative charge, negative pole. Okay, this is an anode. All right. On the other end, this is where reduction occur. So copper 2 plus will go. So because zinc loses electrons, so electrons go pass through like bulb or voltmeter. So electrons are gathered around right here. So copper 2 will go take the electron, receive that electron and become what? Copper metal. So you will see a copper deposit onto the copper electrode. Okay, and the electrode is where reduction reaction occur. Is called a cathode. There we go. It's kind of a little bit memorizing here, so I have a little bit trick for you. One is all alphabetical. If you look at A, B, C, D, E, F, G, O comes before R. So A comes before C. and you just pair them up. So oxidation is anode and reduction is cathode. That's how I do it. Or some people like this. So A and O are the same valves. So those are happen at the same place. Okay, and oxidation reaction happen at the anode, and the non-val, so R and C, so reduction reaction happen in cathode. It's up to you. Either way works. All right. So that's galvanic cell. That's how we be able to use or generate the what? Oh crap! I blank. Be able to generate the electricity. That's what I just know what happened to me today. Okay. All right. Let's move on to salt bridge.